Okay, so here's our second example. For this one, we are looking at an inelastic collision. So what this says is that sometimes the curiosity factor at the scene of a car accident is so great that it actually produces secondary accidents as a result, while people watch to see what's going on. If an 800 kilogram sports car slows to 13 meters per second to check out an accident scene, and the 1,200 kilogram pickup truck behind him continues traveling at 25 meters per second, with what velocity will the two move if they lock bumpers after a rear end collision? So this is an elastic collision. Okay, this is an elastic collision. I'm sorry, inelastic collision, because they are going to lock bumpers. So the two become one. So we called this the rubbernecking accident. Rubbernecking is when you sit and look and watch an accident on the highway or something. So here's my sketch. I have an accident scene. Here's my sports car. It weighs its mass is 800 kilograms and it is traveling at 13 meters per second. Okay, this is before the collision. The 1,200 kilogram pickup truck is coming behind it at 25 meters per second. Bam, they collide. When they collide, their bumpers lock. This is inelastic. Now they've combined. We want to know what's the final velocity of those combined vehicles. So, information. We are given the mass of the car and the mass of the truck. We are given the initial velocity of each. What is unknown? What's the final velocity of the car and truck combined? So, we take a look here and we use our inelastic equation. So, it's mass velocity of the initial velocity of the first object, so that would be the sports car, plus the momentum or mass times velocity initial of the second object, the pickup truck. Momentum sports car, momentum pickup truck before the collision equals the combined mass of the two, because they've attached together, times their total velocity together at the end. So momentum is conserved before equals after. We're solving for VF, so we have to get these masses on the other side of the equation. So this is our initial or original equation, and this is our manipulated equation where we manipulate to solve for velocity final on its own. So we have to take this, bring it over by dividing. We're multiplying here, so we divide on the other side. We get this here. When we plug in, we get 800 times 13, which is 10,400 kilogram meter seconds, plus we add it to the 1,200 times 25, which is 30,000 kilogram meter per second. So that's 10,400 plus 30,000, which is 40,400 total on top in the numerator. And we divide it by the total mass of the new object. So these are combined. So their total mass together is 800 plus 1,200, which is 2,000 kilograms. When we divide those two numbers, we get 20.2 meters per second in the forward direction. And that's how we solve that inelastic equation.